Hello, viewer slash listener. Oh, wait, that's not how I start fall through. Okay, let's try this again. Hello and welcome to Fall Through, your source for deep conversations about software, technology, and computing. I'm your host, Chris Brando, also known as Scriptable, and on today's episode, it's Matt and me, and we're going to be talking about, I guess, the current state of software. I'm sure we'll be talking about AI in there as well, and some other things. We're just going to have a conversation and see where it goes. As always, there will be supporter-only content, so if you are not a supporter yet, you should become one by going to fallthrough.fm/subscribe. And if you're not following us on social media, give us a follow there. If you're watching this on YouTube, please hit that like button and hit that subscribe button and notification bell so you get notified right when we ship episodes. And with that, into the episode we go. Hello, viewer. How are you doing today? It's a nice small panel today of me and Matt. We're gonna be having a little fun conversation, as I said in the intro. Matt, how are you doing today?
I'm good. I'm really good. It's a good day. Getting good sleep lately, and excited to chat.
We love good sleep. It's hard to come by sometimes.
Yeah.
But I guess a bit easier now that it gets dark at literally 4-something p.m. because the daylight savings time ended. I was looking outside.
I know I'm not a big fan of that part, but you know, it is what it is.
It feels like we should honestly flip daylight savings time around. I'm like, you know what I don't need an extra hour is in the summer. Like if it got dark at like 8:30 or like 8 instead of 9 during the summer, I'd be fine. And I would gladly take it getting dark at 6 p.m. now instead of 5 p.m.
I know.
Like yeah, you can get rid of it, or you can just literally flip it around. I need more daylight in the winter. I know it doesn't actually make more daylight, but like in the afternoon, I need more afternoon daylight in the winter.
That 4 or 5 p.m. darkness stuff is like really annoying because you want to do something and you're like, actually, we'll just do it tomorrow during the day.
Yeah,
just like, but we have so many hours left of the day. You know, it's just
right
covered in darkness. Yeah.
I'm like, why is it so dark? It feels so much later all the time than it is. Why do we do this to ourselves?
I don't know.
Anyway, yeah. So today, I thought we'd have a nice conversation about, like, you know, just the state of software engineering. Because I feel like a bunch of our episodes lately have been, we've gotten a little into this. You know, we've talked about things like the cloud outages that have happened recently. Talked about new tooling like JJ. And we talked with, Mitchell about Ghosty and Zig and all of this. It feels like we should just have a nice meta episode talking about what we like about the state of software right now, what we don't like, what we wish would be better. And then we can also talk a bit about AI because that's always fun to chat about. So Matt, how do you feel about the current state of software and software engineering?
Overall excited, but also like overall annoyed. Excited because, there's a lot of cool stuff to learn like in this field. I find the software engineering field to be fascinating. Technology, it's fascinating. There's a lot of stuff to learn. And for me, who is like naturally just curious and likes to understand these things, this all is great to me. The other side of the coin, though, like kind of annoyed, is that too many people are just like, hey, we're going to throw a technology solution at this problem without fully understanding the problem. And they just kind of throw technology like it's the solution to everything instead of just understanding the domain better and then solving for that. So that kind of annoys me. Everyone has an app they want to sell you, but they don't understand the domain that they're operating in. So the app kind of sucks anyway.
I feel like apps in particular are they're so hit or miss. Like some apps are just absolutely great, and then others, the user experience is just atrocious, and you're like, what is going on here? I think especially like when you have intermittent network connectivity, I feel like that's one of the areas where I'm like, y'all, it's 2025. We got to do better at this. Like your app shouldn't be freezing or breaking or like massively confused when there's no internet or there's like high latency. Because it's like, I'll be like trying to look at something and I'll get in the elevator and like the whole app will break. And it's not just like third-party developer apps. It's like even like the weather app for iOS will be like, if it doesn't have reception, doesn't have a signal of some sort. It just like won't tell you the weather, even if it's like, updated recently. So I can like look at it and then like walk out and be like, oh yeah, let me go look at like the forecast for the rest of the day because I'm looking at the temperature for right now. And it's just like, no. It's like you can look at that when you have some internet connection again. And I'm like, why can't you just save that data? Why can't you persist it? Why must you break?
Yeah, that's kind of what gets me too, is it's the rush, not the rush of like adrenaline rush. It's the rush of time that people do with software engineering. They just like rush things out there, try to get a MVP out there or whatever. And you see it in the software that you're using. I mean, like I don't expect software to be perfect, right? I definitely don't expect it to be that. That's the whole point of software. We can iterate on it, make it better over time as we learn more. But I do expect it to be at least somewhat thought out, right? Don't just throw things up there because that's what you did. Like just put yourself in the shoes of the user and understand how this thing is going to be used and like design for that a little bit, because software is designed in many ways, even just your code design and layout, because your next developer or yourself a month from now needs to read it and understand it. So you have to design it well to be understood. You have to design the interfaces to be well. Like all of that stuff matters. And yet we're just throwing things against the wall and seeing what sticks in the name of MVP, move on. And it's sad to me, but we're kind of in this point in time in software where, since software is so ubiquitous and easy to write, that speed is like what everyone competes on, right? I shipped feature X faster than you, even though the feature kind of sucks, and people are optimizing for that.
Right. Yeah, I think we do have an over reliance on, I don't know if it's just speed, but on like the perception of speed. Because I don't think we actually move all that quickly in software. I think we move a lot slower than we tend to think. It's just that we have the perception, at least in the early part of building something, of moving fast. And then you like hit a wall of bugs and a wall of like having to actually do the feature plan you didn't do earlier. At least that's been a lot of my experience. It's just been like, oh yeah, we're moving fast. And then all of a sudden it's just like, oh, now we're crawling. And everybody's like, what happened? And it's like, well, you ran out of gas. Like you didn't do this sustainably. So you ran out of forward momentum.
Yeah, I mean, you see it. That's kind of what bothers me about this field right now. Is you see it, and then you have like there's just a ton. There's a ton to unpack here. You have the social media influencers on there, like influencing away and saying all this crap and nonsense that really means nothing and provides no value to anybody. So you have them like, oh, ha ha ha, I made a to-do app, or ha ha ha, I did this. And it's like, dude, you're not solving any real problems. Get out of here. Like, all you're doing is just trying to engage the algorithm and get your ad money. You don't care about anything else. Then you have like companies holding back true progress because they're afraid, they're afraid of breaking things. So they implement all of this process to prevent change and to make change quote unquote safe. And now you're slower than everything. And you can't even change the background color of something today. You know what I mean? And that's just way slower than it needs to be. When I can do things faster in like the physical world than software allows me to do it, then what's the purpose of software, right? So software is supposed to be a way to automate these sort of manual tasks that we do as humans, or at least make them more efficient for us. And if that's not true, software sucks. Yeah. And it's just like that's kind of what gets me is we've strayed so far away from the value of software in the name of like, capitalism, marketing, getting things out there, getting, just optimizing for sales and whatnot, that so much software out there is crappy.
Yeah. I think too, part of it is like, it's definitely a symptom of the greater world of people not really thinking through to like the end of what they're trying to do. Like, I've had this thing where I like wind up in conversations with people, and this is like not related specifically to software. Although to be fair, like this is part of what holds software back in government. But you have like people all over the place screaming about different things, and like it doesn't particularly matter which side of this you fall on. Whether it's like, for instance, like the we should have a wealth tax in the world. And whether you're like, yes, we should, or no, we shouldn't, I think the thing that people often forget is that like just pumping more money into the tax system does not actually necessarily help fix all of the problems. If like the problems aren't like, hey, the problem isn't we don't have enough money. It's like we're not spending our money well. Like putting more money into the system will not inherently make you spend the money better. I think if I just explain that to people, they're like, oh yeah, you know, you're right there. Or if people like, you know, when they pick their politicians, they're like, oh, but this person's like, I don't like these things about this person. And I'm like, yeah, but what about like the other person on the other side? Do you like them better? Do you want them to win instead? They're like, well, no. And I'm like, okay, well, like we have to do compromise. We have to have nuance. We have to like look at how we actually want progress to happen. And I think people in both like in many spheres of life are like, oh, like we want progress, but we want to take it in one giant step. And like, that's not how it works. People are like, I want to build a piece of software and I just want it to be like one easy thing to do. Or I want to just focus on like, what they call it, like the core competency or like the thing that only you can do. Right. And it's like, that's a great slogan. That's a nice little thing you can say to people. But in practical reality, that's not like what you can actually do as like a software engineer.
Yeah.
Like there's a lot of stuff that you have to write that might be already written before, but like you need to write it in a slightly different way so you don't wind up giving yourself a lot of technical debt or slowing yourself down a lot. But I think like we don't really have that thinking because we are so focused on like silver bullet solutions or like not even necessarily a silver bullet, but like minimal number of bullet solutions, right? We're like, how do we have the solution with the fewest number of things we need to do possible? Yeah. And like, that's just not going to lead to like an effective solution at the end of the day in any realm, but certainly not in software, right? And I think that's what we're really seeing in the current era is that people are like, I want to just I pick my frameworks and my database and all this and I cobble it together and then I can just build my app. And it's like, I don't think that's working anymore. I think that's much slower and much more frustrating than I think we're all willing to admit.
Yep. It's interesting because you have like on one hand, having something that is not just a silver bullet and has some sort of path of adoption is great. And like you see that with a tool like, for example, like JJ, right? JJ supports the incumbent Git well enough to where you can transparently use JJ without anyone else knowing you're using it. So that migration path is much smoother and you can just like use it and move over while it's very clear about the problems it does solve and other features it adds, blah, blah, blah. Great. And like, obviously I know not everything can be that smooth, right? You have to have some sort of like demarcation point where that you stop doing one thing and start doing another. And you want to make that demarcation sort of point very, very minimal so that you don't like introduce like some large change that upsets people. But that will be necessary at some point. But then on the flip side though, you have this sort of stalemate / abandoned solutions where you start down a path, and you see this all the time with like physical infrastructure in the world. Like they start to build a rail tunnel and they stop it. And they pick the project back up again and they stop it. And they keep doing that. And we do the same thing in software. We pick up a problem, we say, oh, we're going to solve finally the problem that customers X, Y, and Z are asking for. And then we stop it. And you pick it up and you stop it. And then now that whole thing has been dragged along years. Nobody has the context of it anymore. You've spent way more time and energy on it. And the customer still needs that solution. You know what I mean? And now they're pissed off because you've been taking too long to implement it. They're going somewhere else. So like the point I'm trying to make is it's a balance, right? You can't go too far in one direction and too far in the other. You definitely have to balance it. But I think that there's real negative consequences to the abrupt switch, right? And there's real negative consequences to this sort of context switch of stop, go, stop, go, stop, go. And we as a software industry, like, don't do that well. We kind of default to stalemates too often.
Yeah, I think it's definitely that planning part is what I mean. I think we said this a lot lately, but that planning part is definitely where we start to just fall apart. Like I get it. Like I truly understand. Like people want to just a lot of people just want to write code. They want to. If you give them a set of tasks, they're like, yes, I will go do these tasks. I will execute on these things. If you tell them what to do, they will just go do that thing. But it's like, I feel like there's like, we have a lack of people that want to do software engineering, and we have like an abundance of people who want to do software building, right? They want to sit down, they want to code the thing. They want to, figure out the bugs. They want to figure out what algorithms to use. They want to do like they want to do like the tree level work. And you need to have someone that's going to do the forest level work, right? You need to have people that are like, I just want to think about, but not like ivory tower architecture. Like that's also awful. Like you don't need someone doing like satellite work, right? You don't need someone in orbit looking down at the entire planet. You need someone that's a little closer to the ground, but not on the ground. And I think that's an area where it's really hard to do that. It's really hard to advocate for that within companies, within open source projects. I think it's also difficult to advocate for that sometimes. So I think it's like we're missing some understanding of what software engineering should be at the end of the day. And I think we're also just missing like because we haven't been doing it, we're missing all of the tools and the knowledge and all of that. There's just like so many things to think about when you want to build a piece of software. And I don't know if maybe there's a book somewhere, but I don't think there is like a book you can have or like a reference manual you can use. It's just like, here are all of the different things that you need to like think about. I think would most likely overwhelm people if you're like, just kind of thinking through it in my mind right now. If you want to build like a back-end service, it's like, okay, well, first, what language are you using? And then like, do you need frameworks for that language? And then what database are you going to use? Are you going to use things like queues and caches or something like Redis? Or are you going to like build that into your app? I guess that depends on the language you're using and the availability of those other things. How are you going to do observability? And how are you going to do deployment? And how are you going to document everything? And like for all of those things, there's like so many different options that you can pick from. And it's hard to like make those choices and figure out which ones are best, because they're all going to depend on like the context and who's around you and what the people around you want to do. So it's definitely not easy to do these things. I think that's why at the end of the day, people are just like, let's just use React and Node.js and TypeScript because that's just there. It's popular. People are using it. Right.
This is where I think the MVP came about, because this sort of software engineering, any sort of, I have a problem and I'm going to create a solution for it and I'm going to design it. Any sort of engineering task, any sort of work, right? It can be as simple as like planning your backyard landscaping. It can be as complex as building an entire building. It can be whatever. It could be whatever sort of engineering you need to do requires careful planning. And planning sucks, right? It's like painting your room. Painting your room sucks, not because the painting's hard, but because the prep work is hard. You got to move all the furniture out of the way. You got to cover the floors. You got to tape off things. All this prep work that takes far longer than rolling paint on the wall. And nobody wants to do that because it's tedious and it's boring. But you can tell when people do good prep work or bad prep work because it shows, right? It shows that there's paint splatter on their floor or that they rolled over the trim work or something like that. And in software, that exists as well, where you can see the cracks in the software due to improper planning. And there was this whole like, I know planning can be like a bike shedding thing too, where you're trying to get to, because you have these engineers out there that are trying to be ultra rigorous and like, we have to be absolutely correct in everything before we take a step forward. And it's like, well, all right, man, I'll see you. You stay at the starting line then. I'll see you like all the way over here if you're going to think that way. But this is where I think the MVP, the minimum viable product, was introduced so that you can like really just focus on what is useful and necessary first. But we've taken that MVP to like the extreme, and it's no longer about like, hey, here's a holistic design. Here's the 5 things we can realistically do in this sort of time frame without losing so much velocity. MVP has instead turned into like, what's literally the smallest thing or the most the most featureless thing we can ship to customers without pissing them off. Like that's what MVP kind of turned into. And now you see all these half-baked apps, video game consoles with huge day one updates because they shipped it before anything, and it's unusable without internet connection until you update it. Like you have all of these design choices now, and the customers are like, what the hell, man? I used to unwrap something, or I used to like open software and things just work correctly. Now it's doesn't. And I don't know. It's interesting to me.
Yeah, in the days of like shrink wrap software, right? You didn't have the ability to just ship someone an update. So you did have to sit down and think more deeply about what you're doing and making sure you got all the bugs out. And it was kind of terrible because it was so slow to evolve the ecosystem. But it feels like we've overcorrected for that now, where it's just like constant updates are being shipped because it's like, oh, we didn't think about that thing, we don't see this bug or whatever. And it's like, it's not like we don't have the tooling. Like, we have, great stuff like fuzzing and other things that could really help us find different types of bugs. But it's also just like, I think the complexity of software has reached a point where it's just too difficult to figure out some of this stuff. And I think we've all just accepted a reality where complexity just has to be the thing we're all dealing with, right? Like, there's no way to avoid this complexity. Like with the whole AWS situation, where it's like you crashed US East 1 because of complexity at the end of the day, because the system that you built follows very standard patterns of what we do in the industry, but like, it turns out those patterns aren't really sufficient against certain classes of bugs that you're probably going to hit at some point if you scale. And given how many outages everybody's been having, it's just like, I think we're just hitting a lot of those, like, oh, well, you're going to hit this at some point. You're going to hit this at some point. It's like, yeah, we're hitting a lot of those some points at this point because the complexity of our software is just eating us alive. And people don't want to listen until something catastrophic happens. People don't want to listen to that, hey, we should really rethink this thing. Because once again, it just like, it eats up time and energy, and people like thinking about the happy path. They don't want to think about all of the messiness of what could go wrong.
Yeah, I mean, I've been putting on my project management hat at work a lot because like we struggle to have a good visibility over like cross team and cross repository projects. Because we all know as developers, a unit of work, right? Like the smallest unit of work is usually like the ticket or like an issue. Hey, bump dependencies. Hey, fix this. Like, small units of work. Then you have these larger units of work like projects that span multiple issues or that span multiple repositories, where it's like, implement this new feature, and that feature has to touch front-end code, back-end code, maybe some database queries need to be updated. The feature has to span across a couple of different areas. That's more like project-y work. And I've been putting my PM hat on at work to really understand this. And that helps me take a step back and view the system more holistically and really understand, like, what are we doing here and what really matters? When you're thinking about these units of work, what really matters? And something that like kind of not clicked, but something that really made itself apparent to me is that there's a lot of context and learning that's just like lost or isolated. For example, in your commit message or in your pull request description or in your AI chat logs, there's a lot of context that you, the engineer that's working on these things, learn, and then you never document, and then you never put it somewhere so that others can benefit from it. How many PRs I've seen, not just even at Oxide or even previous plays, just in general, the general developer culture around pull requests is pretty trash in the sense of no descriptions on these things. Literally, you couldn't be bothered to write a small sentence or paragraph about what it is that you're doing in this pull request. You just have the one-liner title that means nothing to anybody. Like, you're not thinking ahead for, hey, how are my future colleagues going to search for this issue or search for this pull request or understand, are they going to look for, foo, or are they going to look for bar? Because maybe I should put foo and bar in these things to like enable some search. And instead, what you get is a, empty description in your pull request, or even worse, an empty commit message, which if you're doing that, like, come on. And like, you're calling yourself an engineer. You're not an engineer anymore, and I'm not saying for the trivial use cases of like, bump version or something like that. I'm not saying those trivial ones, fine. We all know what that is. But for those more complex units of work that do require more thought, where's your pull request descriptions? Where's your issue descriptions? Why is everything so minimal? You want to write all this code, but then you don't want to write any words to describe it. And it's like, and then you wonder why the software sucks or the skill set lowers or blah, 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 blah. And I just seen this throughout my entire career. And I'm just like, why are people like this? Like, why do we do this to ourselves?
Yeah. Man,
sorry. I'm not trying to be negative. It's just, we have this beautiful software engineering field where software is malleable and easy to be changed and like so beautiful in that regard. And then we just like nah, we're not going to use any of that. Like it's just, to me, it's weird. I'm not sitting here saying everyone has to be a freaking philosopher when they're writing their code, but at least take some time to write it down, because you're going to go on vacation. Teammates are going to come to the code base and they're going to want to understand what this code is. Like, go ahead, go look around. Go look around. Go look at your code. Go look at your readmes. Go look at your pull requests. Go look around and see if people are actually telling the story of the things they're doing, to the way that you can understand it and like move forward. You can't, and I know part of it is, hey, read the code and figure it out. I get that part totally. Like, there's a burden on the reader and there's a burden on the writer for sure, but the writer seems to be not following through sometimes.
Right.
Sorry, that was a long monologue.
Yeah. No, I mean, you can't.
I have monologued.
Given the number of monologues I've done, I think that's quite all right. Yeah. I think that project management point is important, though, because when I think about it, I was kind of thinking about how we were talking about local first in the last episode, and the idea of like latency being like a thing that you just deal with no matter. Yeah. I think it's like, part of the, I don't know if it would go as far as to say like the nature of humans. I think it's like our current learned behavior and the way we tend to operate is to not really pay attention to the things that are invisible or have become invisible. Like, I think a lot about how, like on this continent, North America, there were natives living here for like tens of thousands of years. And they would do things like, the ones that lived in more forested areas, they do lots of controlled burns, and they figured out this is how the landscape works. And they just do a lot of maintenance to prevent like bigger problems from happening. Or they do things, and I don't know if it's in America, but like in some cultures there were like some certain fruits or some certain plants that they wanted to use for things that would only work if like could only be activated if there was a fire. So it's like they purposely set fire so they could do, that type of harvesting, but that would also help do maintenance on things. And then like the US at some point, when we got our national park system, like decided that we're going to have a policy of not doing these controlled burns because all fires are bad. And it wasn't even like a controlled burn thing. It was like all fires must be extinguished by X time or within X number of hours to prevent big forest fires.
Right.
But like in that invisible work that had been done of just like the slow maintenance kind of just faded away. And now we have like massive wildfire problems. Because like we not only got rid of the maintenance, but we also changed how the whole climate works, so that now it's like wildfires are much more prone, and now like we lost a lot of knowledge around how to do controlled burns. And I think that happens in a lot of things. Like, say you do automate a release process, that release process now becomes invisible. So it's like, how and when do you iterate on that? How do you change that? Like, people, it's not even like a having to plan it or anything. It's like it becomes something that's not in your mind anymore because the thing just works until it doesn't. And then it blows up in your face and you're like, whoa, what's going on here? How is this so bad? How has this gotten so broken? I mean, like the subway's a perfect example of this, where people are like, wait, but we're giving the subway so much money. It's like, yeah, because we spend a lot of time like not putting nearly enough money in and not recognizing just how difficult it is to maintain something that is always running and is very, very old.
Right. I have the same sort of problem, really, where like I was giving an example of the release process, making it manual. I write down or open like a ticket or something for the wish list. And this is not the best solution, but at least it's written down. So if I say, "Hey, today I manually created I created a release process that's manual today," great. The goal, the ultimate at the time of this writing and today, the ultimate goal is to have an automated release process. I'll open up an issue saying, "Hey, automate the release process in XYZ. I created a manual process. However, this is not suitable for the future, blah, 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 blah." I'll write it down and put it there. And like, I'll just throw that on the issue pile, and it's going to be more of this like wish list pie in the sky, super not important until it becomes important. But when it does become important, at least there's something there to go see, like, hey, where did we leave off on this? At that time, what did we decide to do next should this manual process become inefficient? And then you can find that issue and you can get some context loaded. And then you can be like, oh, actually, we're not doing an automated release process because we're doing blah, 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 and we're doing something better. And then now you at least have the context for it. But yeah, I agree that invisible stuff, if you keep it invisible, it sucks. Like, it really does suck. And I know my way is not better either, where I'm just creating an issue or ticket and putting it on sort of the backlog, the ever-growing backlog. But at least something's written down about it. I guess. And yeah, that work is actually the hardest stuff, like you said, because its tendency is to be invisible. And then if it's invisible, that means it's like lower priority or whatever. And then it can go on that backlog and kind of die just like due to staleness or something. And we see that all the time in open source, where issues have been open for 4 years and like nothing's happening on it. And nothing probably ever will, but I don't have a better solution yet.
And again, it's not just software that this is a problem. It's like, once again, just like look at our government, which is another like big, it's not really open source, but it's another kind of like big social thing that we do. And it's like a lot of the stuff that people don't like or complain about, or the things that people see are broken, is just like, well, you have to really think about like, how did it get this broken? And how do we not just fix it for now, but fix it indefinitely for the future? How do we get ourselves not into this problem in the future, right? Like, I remember reading, was it Coding America or Recoding America by Jennifer Polka, and Recoding America. And it's a book that basically just goes into like, hey, like over time, the government shifted from being an entity that can build things to an entity that can procure things. And like procurement is cool and all, and we should have a good procurement apparatus, but not being able to build things ourselves is always going to be way more expensive and take way more time, because you have to have somebody else do all of the little things that you need to do. And like, if people want to understand like, why is our government so dysfunctional, a lot of it is that, right? You look at examples of like, you have all these transit systems in America, and they, a lot of them don't have engineers in-house that can rebuild their own rolling stock, or they don't have engineers that are helping design their rolling stock, or, significant, or their signaling system or things like that. And then we're like, okay, we gave you like several $1 billion because this stuff costs a lot of money. And like, now you're over time and over budget and all of that. But then you go look at, not Caltrain, what's I think it was BART. I think it's BART, where they got new rolling stock, but they had a lot of in-house people do like the design work and really understand how everything works. And so by the time they got to delivering, they not only delivered everything earlier ahead of schedule, they also, on like a couple $1 billion projects, saved several hundreds of millions of dollars, because they didn't have to subcontract out a lot of the smaller stuff. They didn't have to like, get stuck in, cycles trying to figure out how something should have been designed, or fixing a design flaw, things like that, because they had all the knowledge in house. And I think like a big thing that people should be arguing for, like in our government as a whole, is like, hey, like the government needs to start doing stuff itself again. Like, we need to stop with the idea that like the cluster line of like the private sector can do it better. Like, the private sector is just people. It's all just people. It's like, but the closer people are, the less communication you have to do, the better. And it's like, there is a world in which the private sector could do it better, but you have to have a much better apparatus of communication and teamwork to make that work effectively. And I think that's the same case in software, where it's like, yeah, you can just like pull this framework or whatever off the shelf and use that. But then if you need the framework to do something else that doesn't do what you need, then you're in a bind. Now it's all of a sudden apparent that this framework's interface, or worse, if that framework becomes unmaintained, or they make some big changes that are incompatible with what you want to try to do, or it goes in a direction of, not having a feature that you need to have. Now you're faced with this big problem of like, well, what do I do now? And it's like, we don't really think about that happening, right? We don't think about the fact that like so much of what we depend on are these giant ships that are steered very carefully by a whole bunch of people, but could very easily be steered in a direction where you get left out. And then you're kind of there like, wait, what do I do? And I think even worse is a lot of times like it starts getting steered very slowly in a direction where you're not going, and it kind of pulls you with it because you're so invested in that thing. Whereas maybe if you had time to sit down and be like, oh, like if our frameworks and things were a lot smaller, people would have time to sit down and say, oh, wait, this thing's not really doing what I want, but this other thing over here is doing what I want. Let me go use this other thing instead. Which is fine, right? I think it's fine to not use a piece of technology, or fine not to use a library or a framework. And I don't necessarily think any of us, whether you're the maintainer of it or the user of it, should see it as a bad thing that people stop using whatever it is that you're creating.
Or just like ask why not this popular thing. I can't stand that. Why aren't you using this? Like,
oh yeah,
because I did the research and I don't need it. You know, like, and there's valid times to ask that question, right? Like, for example, on the Side Arrow webinar I did last week or whatever, they have an integration that takes a Zap logger. Like the actual interface expects a Zap logger. And I was like, hey, like, what? Maybe we change this to Slog or something in the future. Like, that'd be cool. Because Zap logger is a very specific logger and Slog is like more of a generic logger, like whatever. Right. So I asked that question. I was like, why not this tool? But I didn't ask it in the way of like, hey, you're not using the popular thing. Why don't you do like, you know, I understood that when they created their integration or their interface, Slog wasn't a thing, right? Slog did not exist in that way. So they chose the best alternative, which probably was Zaplogger, right? Out there. Because Zaplogger is pretty good. So, and I just asked the question like, hey, are you consider now that Slog is out, like, are you considering blah, blah, blah. But there's people that ask this question in a more like, you wrote your own HTTP server, you loser. You should have just used blah, 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 blah. Like, look at Echo or Fiber or this or that. I'm like, that tells me that you take no, you don't have a process for choosing your tools. You just choose whatever everyone else is using. Right. And that's why you're like asking me to choose whatever everyone else is using, because you actually don't even know why you're using Echo, Fiber, or whatever mucks you want to call out. And that makes me like sad and scared for the future of software, where actual engineers who are smart or supposed to be smart are not taking the time to really understand what tools are available to them and why they're using this. And they seem to be like, oh, it doesn't matter. I just need a like any HTTP sort of server. So I just use whatever, because the goal is to build the product, right? And the product needs to be existing. So HTTP is like, it's just an implementation detail. And it's like, okay, fine. That argument sounds good on paper. But then you fast forward like 6 months, and now that HTTP framework or that they've chosen or whatever is like deprecated, or they run into an issue because they've designed things incorrectly. And now when product asks them, hey, implement this new thing, they can't because they've chosen the wrong tool, or they use the right tool in the wrong way. And now they have this sort of design catching up to them. You know, since they didn't do that design up front, it's catching up to them, and now they can't ship quickly. So like just putting that little effort up front and really just understanding like, why am I using this tool? What is it giving me? And just making a decision and writing it down is important. And I did that for one of the integrations at Oxeye, one of the Kubernetes integrations I've built. It wants like a CLI command. It basically wants you to build a binary that like runs with and takes CLI flags. And they use Cobra to do that. But you only need one command. And I was like, why do I need to import all of Cobra, which is a big CLI library, just to parse arguments and you know, environment variables and configuration and run a command? Like, I don't need all that. So I switched it out for something different because I understood the problem. Because I understood that pulling in Cobra means, you know what pulling in Cobra means? It means dependent bot updates every month. Like that's what that means. And it's just that sort of thinking and engineering is important. And if you're not doing that, that's when that sort of design and craft catches up to you in the future and really just hits you right in the face and says, ding, I'm slow now because I didn't think about all this. It caught up to me. Technical debt, if you will.
Yeah, I think so. Just kind of thinking about how the Unix philosophy, like a lot of what people take away from that is, you know, oh, like each thing should have a single responsibility and like make small things that you compose together. But I think like one of the things that the Unix philosophy forces upon you, and in some ways also the way that like Linux works with like everything as a file, is that like you have standard interfaces and you got to focus on getting those interfaces right. And then like the rest of it doesn't matter as much because you can swap out the thing behind that interface if you get the interfaces right. And I feel like we as an industry are still not really great at figuring out how to design interfaces well, right? Like I know the way that Go does interfaces frustrates people in a lot of ways, but I think that it makes it a lot easier to write good interfaces over time with the way that Go does it, where it's like, yeah, the implementer doesn't have to declare that they implement the interface, and you do have like composability. And like, you know, the fact that for some interface implementations, the way that we actually evolve them is like, we don't add to the interface, we make a new interface, and then you attempt to typecast to that interface. And if you can, and the thing implements it, then good. If it doesn't, you do the fallback behavior, right? This happens a lot with like a lot of the IO interfaces where you have like, oh, we'll take a reader, but if it's a byte reader, we'll do things much more efficiently, right? And I think like that model of things gives you like a whole lot more flexibility, but also gives you a much more stable foundation to build on top of. A much more stable interface to build on top of. And I think that a lot of the other things in our industry just don't really follow that approach. Like, I think the two big ones are like a lot of the way that Go has its interfaces designed, and then also how a lot of web APIs are designed. Not like web REST APIs, but how like the web platform designs its APIs are also very, very small, very compartmentalized, very much meant to be like, oh, you can use this with a whole bunch of different things. Like, for instance, if you're doing like video capture or processing in a web browser, there's this type called a video frame, and you can get a video frame from like a video element. You can also get it from like an SVG element. You can get it from like a whole bunch of different places. And then like anything that wants a video frame, it doesn't care where the video frame came from. It's just like, oh, you gave me a video frame, I know how to process video frames. And like that is how a lot of the web platform is built. And that's part of what makes it so we could do all this incredible stuff in JavaScript or with the web platform, and it can be so incredibly flexible, is because like, yeah, they focused on the interfaces and then they built the stuff behind it after they got the interface down. And I think that part of software engineering is like missing for so many people. They focus on like getting the implementation done, and then like the interface is like an afterthought half the time, or it's like not even there. And it's like, how are you supposed to replace something? How are you supposed to upgrade something if you don't have upgrade points, basically?
Again, it just speaks back to the design. like I mean, that's the premise of this whole conversation is, you know, do some thinking and design. And I don't know, for me, like I try different tools out. I understand them. I try to have that sort of, you know, open mind when you're looking at tools and working and stuff like that. And same thing with code and design. I like to look at things holistically and understand how it works, blah, 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 blah. But I see a fear in a lot of engineers where they're afraid to change their tools or to look at these things. Like once they find their sort of zone in their little path, they want to stay there forever, right? Whether it's something as like, oh, I'm only going to use Vim for the rest of my life because I don't ever want to change. Or if it's like, I only want to use GitHub, you know, issues and pull request. I only want to use GitHub forever because that's all I know. Like I think that's a bad mindset overall. I think it's necessary. Like, for example, you shouldn't just do change for the sake of change. 100%. Like I'm not going to sit here and say like, oh, just change it because we said so. But if you're not open to consider it, like if you're not open to change, that's a problem too. You can't just be like, no, I'm not going to, I have my way. I'm never going to change ever, because you need to come up for air every now and then and take a look around and say, and ask yourself the question, is what I'm doing still the way I would do these things today if I started like today? And if the answer is no, you need to assess whether or not it's worth at this point in time to switch up what you're doing, right? Whether that be, hey, when we started the company, we chose GitHub, and 5 years later, we're still on GitHub. Is this still the platform for us? Should we still be doing our source control here? Like what? Oh, yes, it is. Great. Put your head down. Oh, no, it's not. What are the alternatives? Should we evaluate? Blah, blah, blah. Like that's a healthy mindset. And you should do this in everything in life, not just for work. You should do this with your finances, right? As you make more money or whatever, you should look up and be like, hey, is the budgeting system I have now good? Is my life insurance good? Is the phone I have good? Like, is my exercise routine good? Like, in all areas of your life, you should be periodically reassessing them and saying, hey, this still works. This is what I would still do today. This works for me. Or no, this is not what I do today. I need to adjust. And like,
Right.
That's a healthy conversation. And this industry and software, we're just so set in our ways with certain things that it makes me sad that so many software engineering discussions end in stalemate because you have people that are too afraid to like change the tools that they're using or to change the thing that they're doing when it's clear that it would be better to do something different.
Mm.
And like that, when a stalemate ends because of that, that makes me upset. And similarly, when a stalemate ends because, you know, nobody can like find a path forward or propose things and they're not writing it down, that makes me upset too. Like, at least write it down. At least say, hey, we're not finding anything here. There's no real overarching motivation to switch from what we're doing. We're deferring. Like, just say that instead of saying, oh, it's possible, maybe we'll do it. Like, no, just say at this time, no evidence exists to like switch. We're staying. See you later. Like, make decisions. You know what I mean? Make decisions, man.
And document them.
And document them. Yeah.
Make decisions and document them. Yeah. I mean, I keep coming back to the engineering is a design discipline, right? At the end of the day, what you do when you're doing engineering is design. That's,
right.
You know, I have a friend who is I think he actually just got his PE recently. So he's like a real engineer. He's a civil engineer. And
Right.
I was like, you know, talking to him one day and I was just like, you know, like, what is it that you as an engineer produce? Like, in your job, what do you create? And he said things. He's like, oh, we can create like, I remember that he said like 3 things, but I'm like, those all sound like synonyms for design. And one of them was a design. It's kind of sounds like you just said design. And he was just like, you know, he's like, that's fair. That is like basically what I do. Like, I create designs. That's what I do all day. And I think that we as like software people just forget that constantly, right? We're always forgetting that, like, no, that if you're someone that wants to be a software engineer, like regardless of like what various governments want to say about like who can use the title of engineer and whatnot, but if you want to be someone that embodies the idea of a software engineer, that the thing that you should want to produce is a design, and it should be like a comprehensive design, right? In the same way that like someone who's like a programmer or someone's actually like typing out the code or writing the actual software at the end of the day should want to produce comprehensive software, right? You should want to produce software that doesn't just do the thing, but like handles the error paths well, is debuggable, has good documentation, has good tests written for it, you know, is evolvable. Like, you should want your software to be comprehensive, and you should want your designs to be comprehensive.
Yep.
And, you know, we don't have the equivalent of like blueprints in software.
Right.
We don't have like, you know, things like CAD or stuff like that will be able to, you know, you can't just go in and be like, okay, let me like go test the load of what this software can handle in like a simulated environment, right? Like you can with like CAD and things like that. We can be like, okay, well, how much weight does this wall support and whatnot? Like, we never built those types of tools for us. If you want that stuff, you got to go build it yourself, right? You got to go, you know, like Go has fuzzing capabilities, but you got to like set all of that up yourself. And it has, you know, we have load testers, but you got to like go configure all of that yourself. And it's like, you know, if you ever tried to set up a load testing environment, it is kind of draining to do it well. There's a lot of different ways in which you can mess it up and then get garbage information out of it. And so it's like, yeah, we don't have a lot of that stuff that can help us actually understand if we're doing a good design. And, you know, most of us aren't using things like TLA plus. In fact, to a lot of people, it doesn't make sense to use TLA plus because you're like, wait, but like, I have unit tests. It's like, no, TLA plus is testing your design, not your implementation. It's testing like, is the thing you designed like coherent? Is it correct? And once your design is correct, then you can do the implementation. And you also need to test if your implementation is correct. But it's a whole lot easier to figure out if your implementation is correct if you've already ensured that your design is correct.
Right. And again, I know that there's tension here between like urgency and rigor and all of this stuff where you want to move fast enough to like have a product and you want to move, thoughtful enough to have like a well-designed product. And I get that. And I'm not sitting here saying you need to complete every layer of perfect design before you break ground. That's not what I'm saying. Especially in software, especially when breaking ground in software is not as critical as breaking ground in the real life, right?
Right.
And the listener that may not know what breaking ground is when you have a construction project, breaking ground is like, literally when you break the ground to start getting your foundation built. I'm not sitting here saying that's what we need to do in software. Fully get a design that's perfect and no, that's not what I'm saying. Just get a design that notes these things, right? Note the primary happy paths and the use cases. Note the way you're going to like kind of deal with faults in the system and errors. And if there's an area that you're like not confident in, right? Where you're just like, hey, we don't have real time to devote to this area right now, but we're going to proceed anyway because we have an urgency. Just write that down and say that. Say, hey,
Right.
we did not think about this aspect of the system. We've moved forward regardless.
Yeah.
That's useful information to future readers, because now if someone is going to go there and say like, hey, let me see like what you were thinking about when you built this thing, they can see, oh, okay, you did not think about how, I don't know, for example, plumbing is going to work. So that's why this bathroom is all weird, because it wasn't thought about in the system. Got it. Right. And it's not a way to like judge people and say you were stupid back then. No, that's not it. It's just a way of saying, hey, at least you're communicating. At the time when I had it, like at the time when I made this decision, I explicitly moved past this. Right. And I think that's important. And a lot of technical documentation and design omits that stuff, because it's seen as like a failure or whatnot. But I get it. At the end of the day, you do have to move forward. You can't gone are the days where you can spend 4 years writing a TCP RFC. You know what I mean? Like, you just can't do that anymore. We move way faster than that. So it's okay to,
when it comes to specs, we do take quite a lot. It's actually, we do take longer now to write and roll out specs.
True.
In the past.
Yeah.
But
you know what
also,
I mean? Like, yeah.
Yeah. It's also like, speaking of like breaking ground, like a lot of the reason why you do a lot of planning is because fixing design mistakes with a physical structure is extremely costly the later you get into building that thing, right? Like there's a building somewhere in Manhattan where like they did something wrong and the building's like tilted by a couple inches and they had to like abandon the entire project because it's like you can't get elevators to work in that environment. Like there's a whole bunch of problems. They just had to abandon the whole thing, like a hundreds of millions of dollars project because like, oh, it's off by a couple of inches. And it's like, yeah, no, when those are the stakes, yeah, you have to put a lot of time into upfront planning because you need to make sure that the totality of the building is going to come together in a way that works. And it's rare that people have to work on something that's so large in software that has that type of problem. But like, and it's rare that like fixing things after the fact is going to be super expensive, but there is that same type of thing in software where it's like, if you don't plan this well, or if you don't design this well, you will run into a very big cost overrun down the line. And I think for us, it's very, very easy for software people to hide the costs of what they're doing. Because it's very easy to just cut corners and to smooth over something and make it look like it's functioning well, even though it's really not on the inside, and be like, oh, we'll get to that thing later. Maybe we'll fix it. But like, hey, we got through this big problem right now. So we're good. And I think that's what leads to the massive amount of complexity that we have now, is that we just kind of keep doing that. And we never sit down and we never say, hey, let's actually think of this from table stakes and like go through the process of testing out various different options for things, right? Like, I don't think a lot of people sit down like with a front end framework and say, okay, we're starting a new project. Let's evaluate React versus Vue versus Svelte versus Vanilla versus, whatever. Let's evaluate these different options. Like, and I guess in some ways that's the benefit of building physical things, is that you start the project, you do the project ends, you go do a new project. That new project, you got to make all the same decisions all over again, right? You even something as basic as like, what concrete mixture do I want to use? It's like, okay, well, I need to know about like the soil and the climate and the wind and like all of this other stuff to know what concrete mixture, what type of concrete I should use. And I think that's the same thing. Like for a lot of it, like these frameworks are in effect the concrete of our applications. And it's like we don't sit down and evaluate what type of concrete we need for the type of software we're building. We're like, well, I know React or I know Vue, so I'm going to go use that. And it's like, that's a terrible way to pick something at the end of the day. Because now you're not building and using something that is useful for that. But then also that pushes all those things to basically be clones of each other. Like different types of concrete, like the different ways that you mix them and the things you can add into them, make them a different product at the end of the day that can do different things. And it's like so many of those front-end frameworks are all doing basically the same thing, but in like different ways. And it's like, is that useful for us as an industry to have 5 things that do the same thing? And I don't think it is. And I think it's, even if it was useful for us to do it, it's silly that the reason that we're doing it is because like, oh, I know this one framework, I know this one library, so this is the one I use all the time for all of my projects. Or as a company to say that.
Yeah. And this is not me. Like, I'm not going to sit here and say, oh, there's 2 considerations too. If you have a company and you're building software or whatever, and you design for today, great. And then, I don't know, your app goes viral, right? Everyone wants this, the viral growth, the hockey stick comes. And now your usage is outpacing what your design can handle. And now you're in a situation where you have to reconsider your design, but you're like also in firefighting mode. I'm not talking about that, right? I know that situation, and I know it's impossible to perfectly plan for that. That is not what I'm saying. I'm not sitting here saying like design forever and always be designing so that we, no. Things will happen where your usage will outpace the limits of your design, and you might not have the bandwidth to go like reconsider that design and change it because you're fighting fires. Totally understood. That is not the audience sort of we're targeting. Now, in your initial design, should you have some thoughts or clauses around like what ifs? Sure. But I don't expect you to cover all of this. That's perfectly fine. And like on the other side too is for people that over design up front, that's also equally a problem, because now you're overly focusing on problems that you don't have and not solving for like the now. And I see companies do that all the time, or even in interviews they ask that like, oh, how would you design this so that it never goes down? It's like, first of all, never is, you can't say that. You can't say that. Or like, I want 5 nines. You don't know how much 5 nines cost, do you? You really have no idea how much 5 9 costs more than your entire company's worth right now, actually. So let's talk about that. And it's those things, being real and honest in these conversations are super important. And I understand the desire to like wish list things and move forward, but I also understand the desire to like take your time and plan things. And there, again, it all comes back to balance. I'm not going to sit here and say, let's slow people down or let's speed people up. It's just, I've noticed throughout my career, a very blatant lack of design and discussion and things like that. And I think that software engineering is suffering from that.
Yeah. And I think too, like everybody wants to do the startup thing, even though honestly, you don't need to. Like, a good analog for this would be what has happened with movies and television. I think we probably talked about it on this podcast before, but like, you had the big studios and there was a model. The model was like,
the AI thing, like in my career now, if I'm writing code all day, every day, that's a failure. That's where I'm at in my career, because I can only do so much as one person. And sure, AI can help me do more, 100%. But if I have a team of 3 other people, which I do, right? It's myself and 3 other people on my team. If I can enable those 3 people to do their best work and keep them unblocked and focused, how much more output do I get from those 3 people than just me? Right.
Right.
So so I consider it a failure now if I'm always coding in my role, because that means if I'm always coding, I'm not enabling my team and unblocking them and organizing the work correctly and talking to them. I'm not doing that. And that's the whole point of companies, right? If one person could do it all, you wouldn't see companies the size of IBM with 100 and something thousand employees, right? You'd see companies of 1 if that were, but humans, we can't do that. We have a finite amount of capacity, as much as we don't want to believe that. And the best thing we can do as things grow and scale is to like take that holistic step back and enable others to do their best work in a vision that aligns with what the company's doing. So that's what I'm doing here in my role. And AI is helping me do that a lot, because I can use AI to kind of formulate these ideas, to make sure my designs are going in the right direction, to make sure I'm hitting the edge cases, to treat them as like my little minions in some regard and say, hey, you're my little team right now. I want to create Kubernetes integration XYZ. What do we all need to do? Like, what's the best way to organize this work? And I use that and it gets feedback and it works. And then also I can use AI to actually do the coding and prototyping stuff, which is great too. But what I'm trying to make is every one of us right now is automatically a CEO, a manager, a team lead, whatever leadership role you want to be. We're automatically that right now today, if you treat AI as your your reports essentially, or as your team. And I'm not saying that in a bad power dynamic way of I'm the boss here. I'm not saying that. But if you want to try this on and understand like, hey, how can I better design systems and be more holistic? You have AI at your fingertips to help do that today. You don't need an official title at your job to work through this. And you can kind of work through it yourself and build up your skills and then present that to your broader team and say, hey, here's my vision actually. The back end, we've been running into the same problem with the back end in the last couple of months. It's really drained our resources. Here's a plan to like fix this.
Right.
And I want to get this on the roadmap. And you do that again and again and again, and boom, look at you. Right. So I just want to give that note to the viewer, like, do that. Yeah. I mean, especially if you're an older, like if you're an older person, like I am, like, we're in our 30s or whatever. There are 19-year-olds that spend 20 hours a day coding. I cannot compete with them anymore. I have responsibilities. I have a wife. I have these things to do. I cannot compete with those 19-year-olds spending 20 hours a day. What I can do though is organize those 19-year-olds that are running around, they're running around like a little chicken with the head cut off. I can organize them because they don't understand the holistic system because they just entered the career yesterday.
Right.
So you got to kind of look at that too and see where you fit in your overall software engineering organization and like find that spot for yourself.
Yeah.
Sorry, another little monologue, but
and like speaking of AI, like the thing I wanted to bring up is that like I've changed my I don't think I've changed my view. I think I've reached the point where I can see now, or we reached a point as an industry, I guess, where like AI is now, it's both like a buzz thing and a hype thing, but also just a technology. I mean, they're like, you see it all the time with like programming languages, especially when people are like, hey, like this language isn't doing well because it's not growing, or like if your language isn't growing, then like it's dying or something like that. And I'm like, okay, well, growth along what metric? Is it growth in usage, the number of people that are programming with it, how integral it is to everything, or integral it is to everything that is being built? Like, what do we mean by growth here? But also, like, I don't know, does everything need to be continually getting bigger? Like, can't things just be a size and us be like, right, okay, it's the size, we're good? Like, it feels like that should be something that we can be okay with.
Yep.
So, but this is a long one. This is
yeah, you can't put us on a podcast together because we just do shit.
We just go. It's just like it's like the Energizer Bunny. We just keep going and going and going.
Yeah.
So yeah, I think that's a good place to close it out, though.
Yeah.
Any last thoughts before we end this?
No, just maybe just one. Just go start thinking about things holistically and try to find that value that's more than just ticket closing and code stuff, like start to think about your projects that you're working on in that holistic way, and I think you'll be pleasantly surprised on how that changes your approach to work.
Oh, that's a good ending. All right, now for an outro. Oh yeah, let's just say first, thanks Matt for joining. Always love doing I love when we can be just you and me, and we can just chat. It's always fun and interesting to see where these conversations go.
Yeah, no, it really is. Especially when we have absolutely zero like plan or whatever. We're just like, you want to hop on? Yeah, let's hop on. Great. Let's do it. This for you, viewer, listener, a little behind the scenes here, since you're here at the end. We like literally came up with this like yesterday. We were just like, we gotta record something this week. Let's just vibe about software and the state of everything. And I feel like this was a pretty good conversation. I'll listen to it in post. I don't know how I'll feel after that, but I feel like we got into sufficient enough nuance and depth. I think so too.
To make it a good fall through episode.
Yeah, I think so.
Yeah. But yeah. So yeah, viewer, listener.
When does it ship? Monday?
Yes.
Like Monday, like the 10th?
Yes.
Ah, cool. If you're at KubeCon, I'll be at KubeCon. Come through in Atlanta.
Ah, yeah, go see Matt at KubeCon.
I've been getting people that are like, hey, I heard you on Fall Through. I heard your JJ thing on Fall Through. And I was like, someone comments on YouTube, I came here from Fall Through. I was like, where? That's amazing. So clearly, like, we have listeners.
We do have listeners. This is a thing.
I know.
We do have. We're not just shouting into the void.
I know, it's amazing. Like, I was caught so off guard about it. I was like, wait. Oh yeah, we did talk about JJ. Oh yeah, we did mention my tutorial or whatever. Okay.
Oh yeah, your video. Yeah.
I was just so thrown off guard when I woke up to the comment. I was like, oh. It was like one of those three, like, oh. Like,
it's like, all right, we did talk about
that. We did that. Yeah.
All right.
Anyway, sorry.
Yeah. So, listener / viewer, how'd you like this little conversation between me and Matt? Do you think that the state of software is good, bad, great, awesome? Let us know your thoughts. Social media, in the comments below, all of that. There is an episode of Break this week. There's been one in our backlog that's just been persistent. So we're actually going to ship that to you. It's one with me and Matt, and we just kind of riff on some things. So if this podcast wasn't enough of you hearing me and Matt, then go head over there and listen to us some more. This episode of Fall Through was hosted by Chris Brando with co-host Matthew Sanabria. Fall Through is produced by Chris Brando and Angelica Hill, and our beats are by Breakmaster Soundtrack.
An ASMR intro.
I can give you a potato chip chomp right into the mic.
Oh God.
Oh, I liked that one.
We are a professional and serious podcast. That is what we are. Anyway.
Speak for yourself, but okay. Can we do an ASMR outro?
No.
You know what I mean? Like I know things, I think.
And I was like,
Ding.
that's a good slogan.
Picturing ball being like,
It's the sun.
Somebody that I used to go. Ding.
And done.
Nice.
We did it.
We did it.